Good afternoon, everyone, from the Robotic Surgery Academy from Dubai and from the World Space Week, and with the cooperation with Avatar Medic from San Diego, USA, and the Mars Academy, USA, we feel proud to give this important webinar about space telesurgery. Any audience that have any question can write for us in the chat, and we will feel happy to answer the questions in the end of the webinars. So today our talk is about the space telesurgery and telemedicine that we are offering for the primary International Space Station and the space exploration mission for Moon and Mars, and how the technologies is evolving. And together you will see the technology that we are using and that we are mixing and reaching to this level. Next slide, please. So regarding the Robotic Surgery Academy, actually we have many technologies of it, and which is the robotic surgery, the virtual reality surgery, the space telemedicine and telesurgery, and the artificial intelligence and the training courses. And so this is the Da Vinci unit that we use in our surgeries, and that has the ability to be controlled from distance. And this is the virtual reality that we use in surgeries. And mixing these technologies together have led us to the thing that you will see, which is the space telemedicine and telesurgery. The artificial intelligence is improving, and with the machine language and with the technologies that we can give to the machines, it can simulate the human behavior with the controls of the human to give an abilities to the super structures and results of the states that we can see. Next slide, please. Yeah. So regarding the space telemedicine and telesurgery, we are using the special headsets like Oculus and also the HoloLens 2. And you can see that the transforming of this to hologram fashion from distance, like here in the picture on the left, I was in Dubai, and on the right, I am in Tokyo. The same technology that we evolved more and developed it more with the internet abilities to send this hologram fashion to the International Space Station or to the Moon or Mars mission according to the structures that we have. Whether we are sending a robot or a human and a spacecraft with astronauts. I will show you later on that the spacecraft will be, the missions will be either manned or unmanned with robots. And in the two technologies, we can offer our service. Next slide. If you can see here that the communication and the control area will be in the air, okay? And the telesurgery and telemonitoring will be according to the distance. As an example, whether to the International Space Station, which is in the lower nearest to the Earth, which is about 500 kilometers, and this is calculated when we start sending objects or manned or unmanned mission. And if you can see, when we are going more further to the middle range, okay, whether to the Moon, and you can see which is about 360 kilometers, 360,000 kilometers. And if you can see for the Mars, which is more and further distance, it is about 2,100 kilometers. Next slide, please. Yes. Regarding the missions to the Moon, okay, you can see that, as I told you, it is divided in the manned and unmanned mission. In 1969, the USA and the Apollo 11, which was a manned mission, and all of you remember the videos till now when we saw about the visits to the Moon and what happened there, and it was a revolution, and the history started of the space exploration. After that, in the Luna USSR on February 1996 is also, and this is a Chinese exploration mission. It is an unmanned, and after that in 2019, the China in January 2019. Also, it was an unmanned mission with robots. The reason I'm showing you this diagram that our technologies in the two, whether manned or unmanned, we can provide our primary health services to the astronauts or to the robots that are there, and mixing the virtual reality and to accomplish the tasks. In the Chandrayaan and the Chandrayaan India in September 2019, it was also an unmanned mission which was sent to the moon, and the USA is preparing to launch an important mission in 2024, which is an armed a manned mission, so that it will be more revolutionary and more informative. Next slide, please. Regarding the Mars mission, in 2020, there is 4 Mars missions which was sent, the China HX-1 and the ESA Rosalind Franklin and the NASA Mars Perseverance 2020, which is a robot. I will tell you about the abilities of this robot, and the UAE Hope mission. The technology that we have also, as I told you, it is an unmanned. We can give the technology in which we can supply these robots with the virtual reality technologies, and we can send with them the hologram patterns of the humans to be accompanying these robots in order to do the scientific scan and the studying of the weather and the samples of the atmosphere, or taking samples. And this is very important. And you know how much is the cost to send the whole human with a manned mission, and with the virtual reality technology, we can appear and we can overcome this, whether the risk factor, the radiation, and so. Next slide, please. The other revolution and the importance of robots, and you know, the robots and the robotic surgery was founded by NASA in about 1994. So you can see now a new technology is coming, which is called the robotic satellites. And these robotic satellites is also a part of the space telesurgery, in which that you can see that we can control the robotic arms from distance from the air in order to monitor and see whether repairing the satellites, or even if we have a manned mission doing tasks for their humans.
It was all what was possible. 50 years ago, we pioneered a path to the moon. The trail we blazed cut through the fictions of science and showed us all what was possible.
Very pretty out here.
Today, our calling to explore is even greater. To go farther, we must be able to sustain missions of greater distance and duration. We must use the resources we find at our destinations. We must overcome radiation, isolation, gravity, and extreme environments like never before. These are the challenges we face to push the bounds of humanity. We're going to the moon to stay by 2024, and this is how.
This all starts with the ability to get larger, heavier payloads off planet and beyond Earth's gravity.
For this, we designed an entirely new rocket.
The Space Launch System. SLS will be the most powerful rocket ever developed.
And with components in production
And more in testing?
This system is capable of being the catalyst for deep space missions
we need a capsule
that can support humans from launch
through deep space and return safely back to Earth.
For this, we've built Orion.
This is NASA's next-generation human space capsule.
Using data from lunar orbiters that continue to reveal the moon's hazards and resources,
We're currently developing an entirely new approach to landing and operating on the moon.
Using our commercial partners to deliver science instruments and robotics to the surface, we are paving the way for human missions in 2024.
Our charge is to go quickly and to stay, to press our collective efforts forward with a fervor that will see us return to the moon in a manner that is wholly different than 50 years ago.
We want lunar landers that are reusable,
that can land anywhere on the lunar surface.
The simplest way to do so is to give them a platform in orbit around the moon from which to transition.
An orbiting platform to host deep space experiments and be a waypoint for human capsules. We call this lunar outpost Gateway.
The beauty of the Gateway is that it can be moved between orbits.
It will balance between the Earth and Moon's gravity.
In a position that is ideal for launching even deeper space missions.
In 2009, we learned that the moon contains millions of tons of water ice.
This ice can be extracted and purified for water. It can be separated in oxygen for breathing or hydrogen for rocket fuel.
The moon is quite uniquely suited
to prepare us and propel us to Mars and beyond.
This is what we're building.
This is what we're training for.
This we can replicate throughout the solar system.
This is the next chapter of human space exploration.
Humans are the most fragile element of this entire endeavor, and yet we go for humanity. We go to the moon and on to Mars to seek knowledge and understanding and to share it with all. We go knowing our efforts will create opportunities that cannot be foreseen. We go because we are destined to explore and see it with our own eyes. We turn towards the moon now, not as a conclusion, but as preparation, as a checkpoint toward all that lies beyond. Our greatest adventures remain ahead of us. We are going.
We're going.
We are going.
We are going. We're going.
We are going. Yes. So next slide, please. Next video. So as you saw, actually, can you see if there is any people to admit, please? Yeah. So as you saw, the technology is evolving. The rocket space technology is evolving, and this is why everything is going in a fashion that we feel proud of, the more towards space exploration. Open the video now. Yes, please. So the technology that you will see now is, as I told you, which is the virtual reality, and this was an experience which has been done between Dubai and Tokyo, and surgery of laparoscopic minimal invasive gastric sleeve cholecystectomy, and believe me, it was an amazing history was written in because it was the first world virtual telesurgery. Open the video. Yes, please. You can see here that Dr. Mohammed, I was in Dubai actually, and you can see that this is the live surgery, and I was telementoring the surgery. The hologram fashion that I'm telling you about, in which I can see the environment around me, and I can give decision, and I can telementor. And even if there is a robot, I can fully control the robots. So it is an amazing technology. As I told you, I can put myself to the International Space Station or to Mars or to Moon missions, whether, as I told you, it is a manned, in which it has the astronaut inside, or whether it is an unmanned mission where there is only the robots. The Mars mission, there is a robot from USA which is called Perseverance. And the first time this robot will have a microphones that we will start to hear. And believe me, if we knew them before they send it, and if we put our technology with this, when it will reach in a safe manner and safe landing, we can send ourselves there with the robot, and we can open the system. There will be a delay about 4 to 7 minutes, and even that it's okay. And of course, if we open the cameras of the robot, I can see the environment of the Mars. I can see even if there is a wind or a storm, and we can take even the samples of the robot. Guiding the surgeon. So there is a correlation between what's happening on Earth and the experiments that we are doing, and also of the space. And you can see here the Japanese team, Professor Maki Sakamoto from Tokyo University, and one Professor Shagi, the robotic surgeon from Japan. We made an international team, and we started to do our telesurgery program between Dubai and Tokyo, and between Dubai and USA, and Dubai and other cities. We are building now a robotic program in Iraq. So as you can see, the space technologies, when we speak about it, it's not only for the space, it is for the humans. So the technologies that we are evolving and developing in the space, we are transforming these technologies to the Earth in order to achieve a higher success rate of quality and operation and primary health care. Next slide, please. Next video, yes. Okay. And in this video, you can see that now also we are monitoring. Is there any voice open the voice? Yeah.
So you can see now videos of this technology in space surgery. You can see now the International Space Station, robotic surgery, or laparoscope, like what is Dr. Nada was doing. As you can see now, we can transform ourselves to International Space Station, as you can see in front of you, okay, in order to give a facility of experience or primary aid healthcare to the astronauts if they need. And you know, you have seen also today the launch of Mars mission, which was successfully launched from Japan also. And we are happy today we have the Japanese team also. So the cooperation between Japan and UAE is a very important and go further for the civilization. Yeah. So, Professor Maki, we are proud of the cooperation between UAE and Japan. Did you see the launch of Mars yesterday? Yeah, you saw it? It was a nice evolution for all humanity, the Mars mission. And we will proud to supply this technology to them, to Mohammed bin Rashid Space Station, to use this technology in Mars. Now we return back to Dr. Nadam. He is doing a good job in putting staplers. You can see there is mild oozing. Yeah. Sometimes I can switch, but it's better to put the clips on. Yeah.
Yes. Okay. Open this video again. Yes. Okay. So after you saw the virtual reality that I told you about, and as I told you, it is a mixture of robots and virtual reality and artificial intelligence. Now, this is one of the HD robots from USA, and you can see now he is tele-mentoring and a sort of telesurgery that he is controlling the robotic arm from distance. Here you can see he is controlling the arm from half meter inside the room. We can extend this ability to be extended for more, like to other city, other country, and even to the out of in the space. The robotic arm of HD robots has abilities of artificial intelligence, and we are dealing with them now to build an amazing robotic surgery system that can be used in the surgical practice. In reaching this video, I will reach an end to my lecture to return back to the Telemedicine and Mars Academy, my friend John and Dr. Suzanne. So I'm with you, and John, we are with you, and Dr. Suzanne, the camera with you now.
Hello, everyone.
Yes.
So thanks for setting the stage, Dr. Mohammed. And I think I can share. So I'm John Hanachek, the CEO of Avatar Medic. You'll see the little picture here, but I'm going to bring us into hologram land in a second. But I want to go right off the video you just shared with the Haddington Dynamics robots, because yes, we, myself and Dr. Jewel of Mars, together we worked with Haddington Dynamics to test out a live remote teleoperation of the arm. So I will share you quickly.
So can you put your video on, John? Can you put your video on? Yes.
This is what we were able to achieve over a simple 4G network out from Las Vegas, Nevada to California City, so about 100 miles away. We tested handing 3D printed parts to our simulated medical crew. And this went really well. We were doing this in the middle of the heat of the sun at 110 degrees Fahrenheit in the Mars mission 1126. So this is an analog crew mission where I was the commander. And so you can see that, yes, this technology does indeed work right now. And there's still a lot to do, but there's a lot to do.
We can use it in the space station, International Space Station, to be controlled from Earth or even to the Moon and Mars mission, as we spoke. If it is an unmanned mission, whether it is robots or whether it is a human with us.
Yeah. So, you know, what we saw during this test was that even 100 miles away, the latency is pretty high. So we would want to make sure what Avatar Medic is doing as a company, and I'll explain this to you all in a moment, and I'll back out and explain, is that we're making sure that the robot can work as teleoperation, but also has artificial intelligence. So I'm going to share now this other side of our reality that we've set up in the spatial. So this is the technology that Dr. Mohammed was talking about. here is, oops.
You want
if
me
you
to
can
come
see
on
the
spatial,
screen.
Mr. John, you want me to come on spatial now? I can come to join?
Yeah, sure. Now we can switch over to.
So for the audience, I will go now to the room. You will see that I will put my headsets on, okay? And in such condition, I will transfer myself to the hologram passion, and these are the arm controllers in which that you can see me in the hologram passion that I will be there in minutes. So let me come to spatial.
So hello, everyone. You can see me in hologram form next to, this is the proposed Avatar Medic humanoid version. So we take multiple arms, 2 arms, like we've just shown, put them together with a telepresence platform that can enable us to beam in care. So beam in the care and be able to provide a surrogate for a doctor's visit. So Avatar Medic Inc. is doing this next year. We're going to be launching this system with community hospital partners in the United States of America and any other partners that we may get in the UAE who would like to test this. And our goal is to enable doctors. So we're not replacing doctors. We want to enable experts, and especially remote surgeons, like Dr. Mohammed is a remote surgeon, to be able to also interact with their patients in the hospital bed setting. But this is just the start of what Avatar Medic is doing. We also intend to create, in fact, we have a paper in IAC 2020, which it would have been nice to see you in person, Dr. Mohammed, but I can see you as an avatar, so this is pretty good. And we titled our paper, Avatar Medic, Building a Solar System-Wide Medical Capability. And in that paper, we talk a lot about this, our vision for a flying drone, which can do field surgery. So we take the surgery out of the hospital and we bring it out into the world where it's needed. And this is part of our wider vision to create one integrated system that provides medical care across the solar system. And it will have many different forms using these technologies. And the only way that Avatar Medic can really do this is we also have a great partnership with MMRs, which Dr. Susan Jewell is the founder of. And this is where we can actually test these technologies in simulated missions, because it's one thing to test technologies in hospitals and other places, but it's another thing to test them in the context of space and in the context of a mission, and with different constraints like limited access to communications and limited access to civilization. So that's where that one video that I showed you previously came from, and that's where a lot of the ideas for Medinaut came from, was the real needs of operating these remote missions. So this is a general overview. You can find out more at avatarmedics.space about this. But here we can see. Oh, yes, Dr. Mohammed?
Yes. No, complete. I will tell you later on. Because
you're a bit quiet. You'll need to.
Yeah. So now I want I want the audience to see us, because we put this on our YouTube channel, and we have a lot of audience there. And even some of them, they couldn't join, they wrote to me, and we have 3 participants. Please let them in. Okay. So please, for the audience that you can see now, I'm in Dubai. I will transfer myself to the San Diego, USA. So please, Joel, can you put the camera on me in San Diego, USA? So here is Dr. Mohammed. I will just say hi, and I can see the room inside the office of San Diego of Mr. John, and I can give a form, whether primary health care, of telemedicine or telesurgery. And this is what we meant by transferring the surgery in a hologram fashion from a city to a city. And you can know the distance between Dubai and San Diego is thousands of kilometers away. Yes, John. So see, as I told you, like when I'm here, it's like that's when I will be in the International Space Station. Actually, we send them our request, and we are waiting for their response in order to offer our technology for them. Yes. Yes, Mr. So you can see here Dr. Mohammed in Dubai, and here Dr. Mohammed in San Diego, and in the vice versa, Mr. John in Dubai and also in San Diego. We built an international team of experts in such technology in order to telementor surgery and to give telemedicine and telesurgery in a crisis or in teaching. I'm with you, and the microphone back with you, John. Thank you.
Yeah, it's great. This technology, this is a commercially available technology called Spatial, and this is just one example. We could make, there will be more custom solutions built. Avatar Medic is a platform to control this robotic system, but we can use these platforms now to, like you showed, do these consultations and interactions. We also use them at Avatar Medic to design the system. So like this robots are hard to build. So instead we can test out many of their shapes and styles inside of the hologram. So it's a very exciting way to bridge, because this is what we want the robot to look like. And then you'll see in my video, this is what the robot actually looks like. So it's very style. So the raw materials and the finished designs have a chance to be connected together. I would also wonder if Susan, if Dr. Jewel has, I think she has some content about the Mars program, and so we can look at that, and then we can switch back to Spatial for the end of the time. Is this work?
Yes. Yeah.
Okay, I will let.
Dr. Susan, the microphone with you now to give your valuable information.
Yes. Right. Hello, everybody, and yes, I'm Dr. Susan Ipjewell. I'm the CEO.
Make sure you share.
Yes, I will try to share my. Hold on a second. Okay. All right. Can you see my screen?
Yes, we can.
Yes, we can see.
Wonderful. Well, thank you so much. It's great to be part of this event. And as was already introduced, I am the CEO and co-founder of MMARS, Mars Moon Astronautics Academy and Research Science. And also I am the co-founder of Avatar Medic with John Hanachek, who just presented. And so I'm very fascinated about space, but also when you have humans in the loop, in any time you need to take care of them. So my background is in space medicine and astronautics. So my company here, MMARS, really is trying to offer training programs that will train the next generation analog astronaut that will one day, in the next decade, I probably will be going into space and then also work and live on the surface of a planet like Moon and Mars. So this is what we do. We actually have now, for the last couple of years, worked in analog astronautics. Basically, that's a field that's growing, and it's really bringing in individuals in real time, live, work together, and do testing, R&D, technology, human factors, and they live in what we call isolated, confined environments. So here, we have our MMARS. We've got our own, building our own settlement, our analog training facility settlement in the Mojave Desert, which is about 35 minutes from the Mojave Spaceport in California, United States. So we're pioneering this as a commercial entity, building this settlement, bringing in all the technology that would enable a community of analog astronauts to live together in full isolation. And so therefore we need to build the life support system. And of course, for us here in this picture, you could see we're the first to pioneer and develop the space clinic. And I will show a little bit of the Mars Medic training program that we also offer. But here is kind of the setting of the environment where we're building the analog settlement and the space clinic in the Mojave. And at this point, on the right, we have for the last 3 years deployed in various remote areas in our pods, and the pods are connected by tunnels upper right. But then now we're expanding the vision and building these, using these geodesic domes with connecting tunnels here in the Mojave, which we on our own land that we're developing. So we are also the very first commercial entity to develop the space medics, or you know, you can call it the lunar medics or Mars medics. Still doesn't matter. Space medics. Basically, if you're going to have humans to live long duration in space on the way to a planet, on the surface of the planet, you better make sure you have a full medical capabilities and doctors and medics and so on and so forth. And of course, the idea of long-term settlement on Moon and Mars, where you're going to build these settlements or quote unquote cities, you're going to have the space clinic. And that's where we're heading towards. But in this early stage, we're training the individuals in our analog setting to be analog space medics. And below you can see the multiple activities they engage in when they train in our missions. And here you can see both what we call EVAs, extravehicular activities. That means they go out, wear spacesuit, do the medical triage, search and rescue, evacuation, and then bring them back into our space clinic setting, and they do the telesurgery, teleanesthesia. Obviously, you know, this is our training program, but eventually they acquire the skills that allow them then to be able to not only take that into space, but also here in dangerous and remote environments on Earth. So this is our space clinic paradigm. This is obviously a very early vision of what we're doing. It's a prototype version. This big dome that we do our training inside. And here you could see more of a close-up, and this was John Hanachek's last mission in August. We reopened the training out in Mojave, and there's John there with a robotic arm, the Haddington arm, testing out and working in our teleanesthesia and telesurgery. And the teleanesthesia is something that we're very interested in. I've been doing this work for the last couple of years, and I'll go into a deeper dive. But we also deploy to high fidelity. We've done missions to Nepal at 15,000 feet. Here is at 10,000, 15,000 feet. And we test all our technology as well as our, you know, teleanesthesia, telesurgery. Sorry about that background. And these are several subcategories that we focus in. Not only do we do telesurgery, teleanesthesia, but we also focus on wellness, health and wellness and well-being, bringing in technology to enable the crews that live in ice, you know, in these confined, isolated environments to stay at their optimum peak wellness and physical and psychological, you know, status, right? So here I wanted to show you very quickly how we first started teleanesthesia, where we did remote in these analog astronaut training missions, where you know, they live in confined environments. And this is example what we did with a crew, an analog crew that were non-medical, and that's the key. Is that the question is, can you train non-medical individuals to acquire these skills, and then the acquisition of skills, the retaining of the skill sets over a period of time when you don't have a full medical team on board. So on the upper right, this is an analog station up in Utah desert. On the upper left, you see that Concordia station in Antarctica that's run by the French and Italian and by ESA. And then what we did was the medical team in Concordia station came in remotely at this time, which is in 2014. So the VR/AR technology is at its early infancy. So we were just trying to say, can you remotely from Antarctica to Utah have a telementoring in telesurgery and teleanesthesia to train the non-medical crew? And so over the years, for the it's 2014, now it's 2020, in the last 6 years, we've expanded this basic fundamental research project to incorporate other technologies, which of course is the Avatar Medic, and using AR, VR, and AI to be able to enhance the training. So at the same time, in our training, we're very interested in using technology, 3D printing. So here you could see multiple crews in our missions, training missions, that use 3D printing, and printing life support system tools, printing medical tools, scalpels, you know, hemostats, any kind of tools that you need that you won't be able to bring up, or you run out, or whatever in this remote setting, right? So we tested that. You can see all the different 3D printing. But I think what I'd like to emphasize is our collaboration with Dr. Ishikita with the Vapor Jet, which was printed on the International Space Station. And this is the very first 3D printed anesthesia inhalation device. And so this is now I think the opening of the possibility for us to actually conduct teleanesthesia and to actually bring in anesthesia intervention procedures into space and onto remote settings, because you can then email the files, and then it's 3D printed there in the station, which is what we did, and then we train the crew how to use it. And here you can see it's obviously with a mannequin, but these, half of them were non-medical, some of them were medical in the crew setting here, and we were training them how to intubate, how to use the vapor jet system to anesthesia. And if you can do that, then obviously you can perform surgery. And unless you actually have those protocols and train the crew, I don't think you'll ever be able to do life-threatening surgical intervention in space or on a planetary surface or here in disaster areas on Earth. So here's a very close-up of the vapor jet that we've been doing and testing, validating over the last 3 years in our missions and with the teams here. Won't go into too much detail. And that's it, really. That's the goal of, for us as MRs, is that we're a laboratory. We're a real environment laboratory that can test in real time with real people, right, in the crew, your technology. And for us, the goal is to, be able to enable us to build the space clinic and also to build to create the SOP, the gold standard, gold standard procedures for teleanesthesia, telesurgery for astronauts and for eventual settlers on Moon and Mars. Thanks for listening.
Thanks, Susan.
Yes, thank you very much, Dr. Susan, about your viable work and important, and believe me, working all together and putting all technologies together and expertise. I'm sure we are succeeding, and as you saw the video that we showed, all of us, we are going, and believe me, the new generation, now there is a new revolution, 4 mission for Moon and 4 mission for Mars, and many technologies in the rockets going up and down, and so and even the robots revolution and manufacturers and the 3D printing. So believe me, things is going in a more amazing way for civilization, and all this will reflect, as I told you, what we are doing in the space is reflecting down in the Earth in order to achieve the quality of primary and secondary healthcare. Yes, Mr. Johnson, let us return now to spatial to receive the questions if we have any. So for the audience, if you have any question, we will feel happy that if you write the questions for us, and of course, we will publish our work as you saw every time on our YouTube channels and the social media.